Now, we were doing the factorization of 3260 and we got the factorization with the prime numbers, that is 2 into 2 into 2 into 3 into 3 into 5 into 7 into 13. That can be written as, in the index form, is equal to 2 cube into 3 square into 5 into 7 into 13. Okay, so now the fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? Every composite number, what is composite number? Composite number, we have that number has got more than 2 factors. Suppose 14. 14 is 1 into 2 into 7. 14 is 1 into 2 into 7. So composite numbers have more than 2 factors. And the prime number has only 2 factors, one and the number itself. Okay. So every composite number can be expressed as product of primes, and the factorization is unique. What do you mean by unique? However you do it, it is the same. Unique is, it is the same, apart from the order, how we write. Suppose if it is 280, I factorize, that is 2 into 2 into 2 into 5 into 7, that is 2 cube into 5 into 7, that is equal to, if I write 7 into 5 into 2 cube, that doesn't matter. If I multiply, we get the same 280. Okay. So where 2, 5, 7 are the primes, are prime numbers. 2, 7, are the prime numbers. Okay. In general, when a composite number x is given to you and you are asked to factorize, then x is equal to p1 into p2 into p3 pn, where p1, p2, p2, p3 pn are prime numbers, and p1 is less than or equal to p2, less than or equal to p3. There can be equal prime factors, the same prime factors. p3 less than equal to pn. Now today we have studied that fundamental theorem of arithmetic, that is every composite number can be expressed in terms of prime numbers. Okay, and their order doesn't matter. If you suppose it is 10, 2 into 5. If I write 5 into 2, we got the same number. And in general, composite number can be written as P1, P2, P3, Pn ... where P1, P2, P3 Pn are prime numbers, and this relation holds. Real number continued. So we will solve the sums. Consider 4 raised to the power n, where n is a natural number. And check whether is there any value of n for which the number 4 raised to the power n ends with 0. When a number ends with 0, that means you have to have 5 and 2 as prime factors. So I have written here 4 raised to the power n can be written as 2 square whole raised to the power n is equal to ये 2 बाहर ले गया, 2 raised to power 2n. So there is only one prime factor. There is no 5 in it. So, but a number which ends with 0, it has to have prime factors. It has to have prime factors 2 and 5. But 4 raised to the power n is equal to 2 raised to the power 2n, does not have 5 at the end, does not have 5 as a factor, does not have 5. So therefore 4 raised to the power n will be never end with 0. This is the exercise 1, example 1. And the example 2 we have done in lower classes also. That is LCM into HCF, HCF into LCM is equal to the product of the numbers. Let us try again, let us revise. Find the HCF and LCM of 6 and 20. What is the prime number of prime factorization of 6? 6 is equal to 2 into 3 and 20 is equal to 2 into 5. So which is the common factor out of these two? Common factor is only 2 here. That common factor, highest common factor is 2. That is the HCF. And LCM will be the but first we will take the common factor, then the factors which are left. Then 1, 2 is left here, 3 is left and 5 is left. So total it is 60. Now I show you that now the product of two numbers is how much? 6 into 20, right? That is 120. And the product of the HCF and the LCM are how much? That is 2 into 60. That is also 120. So implies, we draw the inference that product of numbers, product of two numbers, I write here 2 numbers is equal to HCF into LCM. Okay, it's okay. Now have you followed? That is one I have done, how to find out a number which ends with 0. Because when a number ends with 0, it will have 5 and 2 as prime factorization and rest anything you can have. Here, then it is, here I have done, so have you followed this? No, but now there is no 5 prime factorization is here, so it will never end with 0. And the same, again we have got a theory here, HCF into LCM is equal to product of the numbers.